Welcome back to the show. My name is Bret.
Hey,
This is Nirmal. Hi, Nirmal.
what's up, Brett? Hi, good to
My
be
co-host
here.
is back.
Woo, woo.
Where's the heart? Can I? Does it work? Does it work in the live stream? No, it doesn't work in the live stream.
No,
No. It's not fancy enough.
still means the same.
Welcome back to the show. I'm excited to be
Thanks,
here.
man.
This is one we've been planning since KubeCon, London,
Correct.
and you were at lunch with us when we all hung out, right? With Betty.
Yes, absolutely. I believe I was sitting across from you. Or,
Okay.
no, actually,
Okay.
I was sitting across from our guest. So that's where we got here. So,
Yeah, that is. I was yes, the same. Yeah, same thing happened. We ended up in a long conversation about build packs, and we were nerding out, and I loved it. And then I was like, let's have this conversation online. Let's talk about it. So I'm
yes.
excited to get to it. This will be our. We're not really going to talk about Heroku specifically, but I feel like the Heroku team is back on the show. Um, we have Julian in chat. He was here a month ago, maybe. And maybe our friend Betty is watching. Maybe she watches later. I don't know. She
We'll
shows
see.
up maybe sometimes. Shout out to our friends at Heroku, and I'm excited to get to it. But real quick announcements. Nirmal, are we on a podcast?
We are not only this podcast, but a new podcast. A couple weeks ago, we launched. Well, we have this podcast, and
This is the
then
one we're on right now.
this is the one we're on right now. Show me here. Show me now. That's
Show me
where
now.
we are right
And then
now.
this is the future.
Yes, this is the other podcast that we started to dive deeper into all the AI agentic topics that are growing in popularity at a plaid speed pace. um,
Yeah, going plaid.
going plaid. So
So we have two
um,
podcasts, but here's the cool thing. If you're on the Apple podcast, I don't know if Normal knows this, but if you go how can I get there? Uh on Apple, if you go to like the Apple stuff and you click on me, this is a cool feature on Apple. It
there
shows
you
both of
go.
our podcasts, all
Awesome.
branded and
So
everything. Thank you,
that's
AI.
amazing. So, Agentic DevOps is the name of our new podcast. Check it out. It's on all of your favorite podcast apps, or direct download uh, at agenticdevops.fm. Please go check it out. Like, subscribe, and share it with your friends. We're having a lot of exciting conversations over there around all these new topics, but. If you still want the CNCF, Cloud Native, DevOps, Docker content, we're still doing this podcast and these conversations with awesome guests as well. And to find out more, how do folks find out more about what's going on in our world?
Brett.news. That's this newsletter. That's the easiest way to
That's
get
it.
to it. You could go
Brett.news.
to one of these links, but like
Yes,
Brett.news. And
check
and
that
it's a
out.
very infrequent, by the way. Like we've only been sending a couple of months lately.
That's okay.
but it's there to show you what we're doing, what
Yeah.
content I'm creating, what courses. By the way, we got a new course. Stay tuned. I'm just going to show people a preview because I'm excited about this. About this. So this is my next thing.
Ooh.
I'm excited about this. I'm gonna put it in chat for those that are super eager. There's someone there who wants to sign up before this is the waiting list before the beta, before the release, and before the waiting list is announced. If you want to get on the waiting list, when you will learn about my new course, it's going to be all about GitHub Actions, like 2025 GitHub Actions, and how AI intersects with that, and how to use AI in um, your workflows.
Awesome.
And I'm very excited about it. It is all I do when we're not live streaming and having guests on. So if you want to find out about that course when it launches or gets close to launching, I'm super excited. We'll talk about it on another show when I get in all the weeds and details of it. But when I started this journey for this course a couple of months ago, it was based on a course I did 3 years ago. And a couple of months ago, when I started to refresh it and focus it on this thing, I realized it had no AI in it. And then I realized, oh, this course is going to need some AI. And the more I do, the more it becomes about AI. There's just so much to talk and teach. I almost feel like it's going to turn into like teaching people AI just so we can talk about how you use AI in GitHub Actions, because maybe they don't know
Yeah.
MCP, maybe they don't know agents and agentic workflows, and so yeah, so there's going to be a lot in there. I'm excited, but details coming soon. All right, let's get to it.
Yes.
What we here to,
Who
what
do
are
we
we here
got
to
on the
talk about?
show?
We're going to
Yeah. Who do we
have
have on
this
the show?
guy.
Hey.
Hello, thanks for having me.
Hi, Terence. Thanks for being here.
It's been
All
it's
right,
been a few months.
it
Yeah.
has. We all had lunch at KubeCon, and we got on the topic of build packs. And this is Terence Lee, everyone. He's from Heroku. We're going to talk more about him and Heroku and stuff in a little bit, but we're going to jump right into sort of defining what build packs are. I mean, there's probably people that have watched it. I have the hat. It's one of my favorite KubeCon
Ooh.
swag hats. This is the build pack logo if you've ever seen it. And
Where's my hat?
I've been around. What's that? What?
Where's my hat?
Yeah, sorry. Yeah, you didn't pick it up at KubeCon. Like you didn't go by the
No,
booth.
I didn't.
Um, so take us back a minute. Everybody started with Dockerfiles, and then we had a lot of ideas and things around like how to build containers, different ways to build containers, different tools to build containers, different formats. And then, Dockerfile still kind of has settled as sort of the default for a lot of people. It was the first thing they learned, and they didn't really move to any other tools beyond that. And then I remember, because I was early days Heroku, we had a whole show with Julian on a few months ago about sort of Heroku's journey. And I was an early user of Heroku. I was a huge fan of sort of the easy button for deployments and running apps. They defined the 12-factor app. Like there was all this sort of early innovation in the early 2010s. And we had something called Buildpacks, but that's not the same as what we have today. And so when we say Cloud Native Buildpacks, we're actually talking about something new, right? Or newer than the original term Buildpacks was coined. Can you tell me a little bit about that, Terence? Like I'm not exactly clear where the differences are and where Cloud Native Buildpacks originated or when.
Yeah, that's a great question, and it's probably confusing that we stuck with the same name for better or worse to some degree. Because
Naming is
it's like
hard.
when you talk about build packs, which build packs are you talking about?
Yeah.
So when you're talking about that Heroku experience, we have, I think we're labeling now like classic build packs, but in the Cloud Native Build Packs project, we consider that like kind of the V1, V2 version of the API, and we consider Cloud Native Build Packs kind of the V3 version of build packs, essentially, like a major version change that tries to take a lot of the great ideas and things that you were talking about, right? It's like I want
Yeah.
that easy one-click deployment kind of experience to be able to build an app. And I think one of the downsides with all the like Heroku's great, and there just weren't as many standards back then of like how I package up an app. Like Docker didn't exist, right? Like uh so what did you have? You had like tarballs, you had AMI images, people doing pup and
Right.
chef, right? So
Yep.
Heroku came around and built a thing using tarballs essentially that we called slugs, and that's what happens on the platform today when you're using classic build packs. You had other kind of people in the space with Cloud Foundry. They had a thing called droplets that were very similar, right?
Mhm.
And so you had these basically proprietary formats. So it's not that you couldn't run a slug on your local machine. It was just a lot of work. And I think one of the wonders of Docker that really changed so much stuff was like it made it really easy to like containerize an application and run it somewhere, right? And so um, the ideas behind Cloud Native Build Packs is like, can we take all the great ideas and things we had in Cloud Native Build or in the Build Packs era, but use standards, right? So instead of producing a slug, why don't we produce an OCI image, right? And that means like I can Docker run that thing locally. I can push that to an OCI registry. That means it works with Kubernetes and all that stuff because the interface with that is OCI, right? So that was kind of the premise behind a lot of the ideas behind like the difference between like the standard classic build packs and cloud native build packs, right? It's like this idea that we want to be able to play in the ecosystem. And the benefit to everyone else is that for us, like we don't have to go and build all those tools, right? Like
Yeah.
if Heroku didn't go and build the thing that lets you run a slug locally, maybe someone open source to do it, but probably not, right? Like the ecosystem is not big enough. But like I think with Docker and kind of the whole cloud native kind of space is like people are going off and building those tools, and we don't have to. We can just play in the sandbox with everyone else.
Yeah, nice. And I remember I kind of when we were talking at lunch, I think I asked a sort of question around if we were in an elevator together and you had like 60 seconds to convince me that to try build packs, if I know Docker files and I understand the premise of layers and how images are built and some of the core principles, I guess, of image formats and image making, what would I be looking to cloud native build packs to solve?
Yeah, I think the real target audience of like why you would choose Cloud Native Buildpacks over something like Dockerfile, even if you are a Dockerfile expert like you are, Brett, is standardization, right? Like I think Buildpacks are really built for coming out of a platform like Heroku, where we need to be able to build images at scale on the platform for so many different users, right? And I think at the end of the day, when you have a Dockerfile incredible tool. We use them even in our own project, right? We use them at Heroku to build our base images and all those things. But what we also need to be able to do is be like Ruby apps, no matter how they look, like they all have to be built the same. Same with Java, same with Node, right? You want to be able to encapsulate a technology and be able to standardize how that thing is done across the entire company, across the entire customer base, because that allows us to have these narrow conduit, high leverage teams that aren't very large that allow us to basically impact and improve the developer experience for all of our customers or all kind of our employees, right?
What do you mean by high leverage, narrow conduit? I've never heard that term before. What does that mean in
I just think of
respect of it?
like one of the things that's really neat at Heroku as a concrete example is that we have a languages team, and basically their job is to own the language experience for the platform. And so that means you have a person who's dedicated to all the languages that we support, and they live, breathe, and eat that ecosystem. They maintain those build packs, and through build packs, they're able to basically as one of the tools that they have, they're able to basically control what the deployment and kind of operation experience of what it means to build an app on the platform, right? And we're able to do that in a single way. And, I think if you have a Docker file, like they can inherit the thing, but ultimately, like if I need to go and like have a customer update that thing, right? Like they have to make changes in their app in the repo, like inside that Docker file, right? And on our platform, because of build packs, we're able to have that engineer kind of change the build pack and be able to deploy that out across all of your customers, right?
I see. So it enables, so to kind of translate this to a potentially like a platform team at one of our listeners' organizations, that platform team might be also responsible for the different guardrails for different workload types, right? Different languages, different libraries. And if they were creating Docker files for their base images, it would still be a challenge managing all the different permutations or creating the right abstraction for their development teams that doesn't overwrite or step on the toes of what the platform team or the guardrails that they want to keep in that existing Docker file, for example, right? Without just like creating tons of different forks of that file in different ways. So with build packs, potentially that platform team can use the build packs framework to implement that right abstraction that allows the different development teams to have the flexibility to adjust certain parameters, but also not destroy the guardrails that the platform team wants to enforce. Is that
Yeah,
kind of the
yeah, I
way
think
to think
that
about it?
yeah, that's a good way to put it. Like I think a good example, for instance, which isn't too even different from the Heroku example I just said, is that I think it's not crazy to imagine that a medium to large company, like let's say you're a Java shop, right? And you pay Azul for some contract of like a JDK. It's supported. You have a certain set of runtimes that you want, right? And you want to be able to have a single place where you can enforce those guardrails like you're talking about or those policies in place. Kind of no different from, I guess, like OPA or those kind of things for other things. But like as part of like the build process, you could have, for instance, like oh, like I could put deprecation notices like in the build as part of that, where it's like, oh, this version of the JDK is going to get phased out. Like this version of Java is like not going to be supported in 6 months, right? And then since everyone has to go through this golden paved path, for instance, when you do remove it, like the build will fail to build, right?
Yeah.
Because like you're controlling it there. Whereas I know how, I work at Salesforce, I work at other companies, we've worked with a lot of people, like how it works with Dockerfile, right? Is like you have those base images, but no one stops you from continuing to use that thing, right? No one stops you from continuing to use that stuff. And so
All right.
if you can't have a centralized way to control how, like, I think the platform team can control a good amount of like what they're pushing out, but it is ultimately on the app developers oftentimes in these companies to like take those things and then build their own build pipeline, and make it align with the paved path as much as possible.
Yeah. So in the past, I think that what you're mentioning here is when in the deployment lifecycle for an application, uh, in the with Docker files, or what I've done in the past with platforms is it's typically way later in the deploy in like the CD process where some enforcement of guardrails happens, or even later, like, oh, let's check what's actually running, and like things with OPA, like what you just mentioned, what base images are out there, versus doing this like already in the spec to the left of the development process, essentially.
Yep, exactly. And then you can have like it allows them, I think, have, because it's programmatic in some ways, a fine kind of controlled tool to actually do that, right? Kind of at that level.
Yeah. So if we back up a second real quick, I'd like, so when, if I'm someone who wants to make a container image, and all of these things we're talking about today are OCI image compatible, which means that they'll run in Docker, they'll run in Podman, they'll run in Kubernetes, they'll run anywhere, regardless of how we're building it. In fact, there's probably at least a dozen tools out there that can build images. Sometimes they're specific language versions, Java or Go. Sometimes it's like we have Buildpacks, we have Docker Command. You can use other, Red Hat has some things, Builda. And all these things produce the same result, but the way we get there is different. And because the result is the standard and not necessarily the build process being the industry standard, we can see all these innovations. So what we're talking about here is I can make a choice of like, if I'm writing a Docker file, or if I'm thinking of writing a Docker file, if I want to choose Cloud Native Buildpacks, I don't need that Docker file, right? Like this is a Docker file replacement, essentially.
Yes, that is correct. We don't use Docker files under the hood. We don't like produce a magic one behind the scenes. Like we essentially create the layers and then build the container image, basically as part of the tooling, and then ship that off to the registry
Right.
or
So
into the
you have
daemon
this
or
pack
whatever.
CLI, and the pack CLI replaces my Docker build, my Builda, my I'm trying to remember the Java specific one, whatever that one's called. There's a Golang one and a Java one that I can never remember the names of because I don't use them. But like all these different build tools that are out there. So I would be using the pack CLI, right, either in CI or as a human, and the res- and the idea there is that we're reducing complexity, because so a lot of people reading a Docker file nowadays is like it's pretty raw. I mean, it's a pretty raw format. You're doing very minutia controlling of files and permissions, and you have to deal with effects of layers, and there's a lot. I mean, I could spend 5 hours at least teaching Dockerfile functionality and build kit things that Dockerfiles use. Like it seems simple at first, but it goes deep real quick. And there's a reason people keep taking my Docker courses, and I'm assuming it's around some of the Dockerfile stuff. And of course, AI is making that easier now. But we've all sort of accepted Dockerfile is like it's a burden, and it's a thing we've all got to figure out. And then you end up, at least the teams I work with, one of the negatives of it is you end up with that one person in the team. And this was kind of true of any system, whether it's CI or whatever. There's like that one person in the team that knows how the Docker file actually works. And I think they wrote a lot of the more advanced stuff. Maybe they use some of the fancy front end things that Docker files now support. And so a lot of times when you get to enterprise, I feel like with Dockerfiles, unless it's something super simple like Go, the compiled languages tend to be a little easier than the the dynamic languages. But I end up with teams end up having to ask, okay, who's your Dockerfile expert? Because there's usually like one, maybe two people in the team, and they're the ones that know how that file works. We see that in other things like CI, where you tend to have that one person who knows how the CI files work and whatnot. But I never liked that. I always kind of wanted everyone to understand how the software was built. I wanted them to understand dependencies better and the effects of Docker files and things like changing users and permissions and all that. It is all that get better with build packs? Is that something that I, as like a DevOps person, I can control better and reduce the burden on a lot of those details with my developers?
I think the answer is yes, but obviously I think it is mostly because it formalizes the contract a little more, right? Like
Okay.
I think because the fact that you have someone who's like writing the build pack, uh, essentially what you're saying is like the one person on that team, whether that person happens to be in DevOps or wherever, right? Like in our case on Heroku, that we have a languages team that does that. But you're essentially formalizing the contract a lot more, whereas like it just happens to be the one person that you're talking about on the app team who happens to know the magic incantations
Yeah.
of like the advanced Dockerfile things. In this case, it's like I'm not like I actually think like the beauty of Dockerfiles is how, like you're saying, how easy it is to get started, right? Like it is so powerful, but like writing a productionized Dockerfile, I think
It's a dark
takes
art.
yeah, it's a dark art, right? The dark arts of Dockerfile. Um, and I
One that
think
I
that's
consult for,
yeah,
by the way.
yeah.
One that I've actually benefited from financially because I've had to help people with the multi-stage and the test versus production images and like yeah. I don't shy away from a complicated 300 line Docker file, but a lot of people probably would. But anyway,
Yeah,
sorry.
and to some degree, like I feel like a lot of the stuff, to kind of put this tangent out there is like, I think part of the things that we're trying to solve against is like, I think if you're an app developer, say like 10 years ago, kind of pre all this stuff, like
Hmm.
I think you had to know a lot less, right? And I
Hmm.
think in the modern cloud native world, like as an app developer, not only do I need to be a full stack app developer that knows my stack top to bottom, probably some of the business stuff as it relates to my app, like I need to be able to containerize my app to some degree, right? Like
Hmm.
that's what we're alluding to here. Potentially you have to be able to operate the app inside of a Kubernetes cluster and other those things. And so I think you're starting to just see a lot more of these DevOps things leak through of like, this is what it means to be an app developer in 2025,
Yeah.
without even getting to the AI side of it, right?
Yeah.
Um,
Yeah,
So,
we created all these different abstractions, but we didn't necessarily create new job layers for each abstraction. So there's
exactly.
someone who keeps getting burdened with another layer of abstraction every time we create one. Someone's got to take that on.
uh,
There's probably an
Yeah.
XKCD about that somewhere, but yeah.
I'm sure there is. So, with this different approach to building containers, it seems like there's a lot of different features or advanced things that you can do with build packs that you might not necessarily be able to do with just a Docker file. What are some of the exciting things that you can do with build packs that might be some attractive for someone to leverage and start using them?
Yeah, that's a great question. I mean, should we just like do a build pack build? Is that the
Sure, yeah,
Yeah,
and
we can talk through
I
it.
was
Let's do it.
I
yeah,
was
let's
also alluding to the features page, which has like a bunch of really cool things listed there. So yeah, go
yeah,
for it.
I think there's a bunch of cool features and it probably depends on should I share my screen?
Yep.
Is that the
Yeah,
best way to get
you are
started?
shared. I was going
Yeah,
to show the features list real quick that Nirmal was talking about. I hadn't actually gone through it. There's a lot of
yeah,
stuff there.
there is.
Yeah, I think for the most part, like you can do a lot of these things in Docker
Oh, that's
files for
cool.
sure, or in OCI images broadly in the spec, right? Like we're not doing things that break the spec, but you just have to know how to do it, right? Like,
Co.
um,
Sorry. Jib and Co. Yeah.
oh yes, Co. There's also Jib, right? I think Jib's the other big
Yeah.
one from
Yeah.
that's like language specific you're alluding to.
Yeah, that's a cool comparison chart. That answers I mean, it doesn't really truly answer the questions, but at least gives me a sense of like uh if I'm like rebasing. We don't even really use the word rebasing when we talk
Well,
about
I think this is a
Docker
phrase
files.
that came out of Buildpacks essentially. I think we obviously cargo culted it out of Git, and I think it's one
Yeah.
of the coolest features in Buildpacks, and we can definitely uh, jump into that today as well. But essentially, because of the standardization with Buildpacks, we actually know the seam of like where your app's the base image ends and your app starts, like where that seam is. And so we like write like one of the restrictions of the standardization is you write your app layers in very specific spots, right? So you can't just like splat it across anywhere in your directory. You don't have access to root. So like build packs don't build with root level controls. Like you're
Hmm.
expected to build with a user level control. So you can't do like an apt-get install or a yum install or those kind of things in a build pack.
Hmm.
And so what that gives us, it means that we know you aren't mucking with the base image, right? And so the benefit of that is it like one of the things that we have at Heroku that we wanted to carry forward was if you're building millions of container images, like what do you do when a patch OS update comes
Right.
out and you got to
Right.
patch the
A
OS,
nightmare.
right? Like it, like I know the answer in Dockerfile for most people is like, and I know how this works at a lot of companies is like you have some automation that goes and like changes that from line, which then blows through the cache, and then you got to rebuild the image, and it's like it's expensive, right? Like you're doing
Yeah.
compute to essentially not do a code change, but do like a patch, right? And one things that we can do is that if you are using a like LTS, like an Ubuntu LTS, your RHEL 9 kind of thing, right? Where they make like ABI compatibility guarantees at the OS level. One of the things you can do is you can actually just do a lift and shift and swap and replace those layers. And one of the neat things with like the OCI image format, the Docker V2 image format, is that it is just a JSON file, right? So like you can actually just go and swap the layers in the array and produce a new SHA with the image with the app layers on top. And that image with that ABI compatibility guarantee should just boot, right? And should just run without incident. And that's a thing we've been doing pre kind of OCI stuff on the Heroku
Right.
platform. So we feel very confident about it because we literally replaced the base image layers out from under the slug. So we wanted a way to carry that technology or that like kind of pattern forward into the
Right.
OCI image world.
Yeah, because you're right. Like most of us start small, right? And companies, when they were adopting Docker, they started with the first image. That was always a big lift. And then they, especially if it was like monolithic or legacy apps that had a lot of complicated. I mean, in my early days, I was using a lot of Ruby and PHP apps that there was all these layers of dependencies. Like with PHP, you would do apt probably, and then you would have Perl or not Perl, pair. They had their own pair thing, and then so you had like two or
Yeah.
three. You probably had to put npm in there because you probably needed some other things from npm that weren't in pair. So you had like at least three different dependency installers, and and anymore every time I have to still see a decade later an apt-get command inside of a Docker file, I like a little part of me dies, only because that like package managers in Docker images, while I honestly think without them, Docker would not have taken off because it allowed you to lift and shift really easily. Like every app was going to work no matter how crazy your build process was. Like it had apt, it had yum, it had npm. You could do all these things, right? But the longer we do this stuff, the more that that I see all the effects of that. The amount of CVs, the amount of having to rebuild every image. If you're really trying to stay on top of things, like every week, every other week, like you're building constantly just to stay up with CVEs and latest and refreshing of dependencies. And I've grown to like I see apt commands and yum commands and Docker files, and I get anxious just because I know that's like you're saying, it's kind of like modifying the core, the base, and it makes things so much more complicated in my build processes and testing. And if I'm in a long-term stable image, the apt packages probably aren't the latest thing we want. So then we're adding custom ones, and it really starts to get out of control. And if you look at this, we're going to talk about security in a little bit. I'd love to talk about like see scanning. Like everybody's all focused on minimal images and secure images, and it's when you're using apt and yum, it's actually really hard to do that, like to pin versions and to
Yeah.
update the pinned version to the only the patch release. Like these are all actually pretty hard and complicated things when you get outside when you get to the OS level package manager. So I've actually in the last couple of years, especially thank you to ChainGuard, I've wanted to like remove any apt and yum from all of my images and to only use like at worst something like an npm or a Maven or some sort of application package manager or language package manager rather than the OS package managers. I feel like those were like got us through the first decade of Docker, but I feel like we should move on from that. So it's
So
cool
Yeah.
that you're mentioning that because that's a problem I've been feeling for years.
can we see what this looks like?
Yeah, let's do it. Do you have my terminal up? You do.
Yep.
Okay.
Yeah.
So we mentioned the pack CLI. This is kind of the easiest way to get started. You can brew install it. It's in a lot of the distros, and you can just go to github.com/buildpacks/pack. And if you want, just download it old school style through the GitHub releases. So it's essentially the CLI. We consider it like one of the platforms, and it works on top of a Docker or Podman. I think we default to Docker by default, but we have folks working with the Red Hat folks as well, and they definitely are using Podman on that side, and people have opened up issues and we've patched them. So the main one, if you're basically going through as an app developer, the command you care the most about is going to be build. And so one of the things that I have done that we haven't talked about. Oh wait, is my terminal too big?
I think it's not snapped to your window
Yeah.
completely.
Oh,
yeah,
yeah.
it's a little.
There we
It's
go.
like cutting off the bottom and the right. It looks like. Oh, there we go.
Oh, can you see it now? We're good. Technical difficulties.
Let me fix
Okay.
this.
Are you
I'm
Oh, the
fixing
good?
it
left
on
side
my
is
end.
being cut. Yeah.
Yeah, it's mine. I gotta resize my window. So all right,
there we go.
We're good.
That's
We're
good.
good.
We're good. Awesome.
Ready to rock.
Okay, so one of the first things that you'll learn about is there's also this builder command. And so builders are essentially a way to package up a base image with a set of build packs. And so allows it to be somewhat self-contained. You can pull build packs kind of from the registry and other things, third party, locally, if you have your own written, which we can take a look at as well. But there's a few build pack vendors, Heroku being one of them. There's Google build packs that are specific to Google, and then Paketo, which is an open source project out of the kind of Broadcom folks as well, with Tanzu, that have a bunch of open source build packs that people use as well. And in our case, since I work at Heroku, I'm most familiar with the Heroku build packs. You can set a default build pack. So I'll set the default builder to the Heroku builder 24. And this is based off of the Heroku 24 base image, which is essentially Ubuntu 24 LTS with, the few minor packages that Heroku wants to make it a good experience to deploy on the platform for if I'm building a Ruby, a Node, whatever app, like dependencies that I would expect to kind of be in there, right? And in here, this is just a Heroku getting started guide, but it's just a standard Node app that isn't, I think it doesn't do a whole lot, just like an Express app. I don't think there's anything super proprietary in here, but it's like, okay, I got EJS Express, doesn't do a whole lot. And you can pass your own builder here, but since we set one, we don't have to. And then essentially, I just want to specify an image name inside of Docker. So I'll just call it Node.js getting started. And it's going to kick off. And if you don't have the kind of images pulled down, which I did for this, for speed reasons, it'll go and fetch it. And by default, it's going to always fetch the latest kind of thing, because we always want people to generally be using the most up-to-date version of all these things. But there are flags to basically, if you're demoing this like at a presentation where the internet's potentially bad, you may want to like skip it. So there's flags for that. And so the first step you'll notice in here is like is that the builder has a set of build packs, and in here, because I have a Node app, it's going to detect I want to install the Node.js runtime and also like run npm install, because that's the dependency manager I have. And then it goes through and essentially goes and figures out what version of Node I'm running, uh, and then runs npm install for me. Procfile, if you use Heroku, is the very familiar like Procfile file for setting the process type. So it's going to pull that from the Procfile build pack. And then these are essentially all the layers that get set and defined inside of that build pack or that app image at the end. And then when we save it, it gets exported as essentially an image, right? And so since I'm using Docker, I haven't tested this, but we should be able to just boot this. So Docker run just kind of boots that up and gets it running. So that's like the 0 to, the like Buildpack 101 as an app developer, just like, am I just getting started? And so I have this image here, right? And so I can Docker push this to any registry I want. I can, it's in my Docker images here. Right here, right? I built that. One of the questions we get a lot of times, actually, speaking of features, is this 45 years ago question. And so, like we do the epoch timestamp thing. And one of the things, so you can set this to any date you want, but one of the things that we do in build packs is we want to have as close as possible deterministic builds or repeatable builds, essentially. And as I'm sure you both know, like timestamps get factored in when like you're calculating like the SHA for a layer and if the layer should be repeated or not. And so one of the things that we do is that since we set the timestamp for all the files after the fact when we export it to the epoch time, which is 45 years ago. And essentially what that allows us to do is that if you have the same bytes on disk, you will get the same layer SHA every time. So the benefit of that is that we can go ahead and kind of just, have that decrease essentially like the layer differentials that are going to happen based on actually like changes in the layers and not changes in timestamp. So that helps
So
us
you
a
can
lot
find the
there.
build. Is it like metadata where I can find other metadata where I can find the build date instead of the Docker's default there?
I don't know. Like, I don't think we necessarily have. Let's see, I don't.
Like, I
If
mean, automated
inspect.
systems would do SHA comparisons, but as a human, if a human wanted to know when the image was built,
Yeah, so we have like the tag time and stuff like from the
okay,
metadata
there you
on
go.
the Docker
Yeah,
image itself, and so you can use that essentially. Um,
yeah. This is basically just. It sounds like to me like you're trying to improve on some of the side effects of the traditional Docker build. That, I mean, Solomon. I don't know if it's been on this show or not, but Solomon Hykes, one of the co-founders of Docker, we had him on recently, and I know he has said recently, like talking about Docker got so popular so quickly. And Nirmal, maybe you can remember this if he did say this on our show. He talked about Docker, that became so popular so quickly. They were limited in the ability for them to iterate and innovate in those early years when normally they would, but they were so concerned about breaking backwards compatibility that a lot of the ideas in the first few years weren't they couldn't just change them later. So he actually talked about a little bit of the negative side effect of getting popular so quickly as a tool is that you're not allowed to just break things to experiment anymore because now that millions of people are using it that way, you're kind of
Yeah.
you either have to find a non-breaking way forward or just be okay with the limitation. And it was an interesting that's an interesting story around like there are innovations that you could have when you all designed Cloud Native Buildpack, you were able to sort of take some learnings, and since it's a new idea, you didn't have to so much worry about those the side effects like Docker did. So that is an interesting little.
Yeah.
If I do
I
is
th
there a pack equivalent for looking at images that maybe give me different information?
Yeah, so this is pack inspect. So you can do
Okay,
that
there you go.
on
Yeah,
an image
I
here,
didn't see
and
that.
it gives you kind of so all this stuff, a lot of this is actually stored inside of
The
the
image
metadata.
metadata.
as labels, and we essentially parse a lot of this stuff out for you, so you don't have to,
Yeah,
it's like I think a handful of tools in the space definitely do this. It's like
right.
jam a thing, a structured data into a label,
Right
so I
to a
don't have to like
string.
open
Right.
the image, right?
Yeah.
And so that's what we do. And we definitely have some like files on the image itself too, but anything we want
That's
to be
actually
able to
cool.
quickly
Like that
get.
output, by the
Yeah.
way, is actually pretty cool.
Yeah,
Yeah. So
Very, very
yeah,
human
useful.
readable. Yeah.
yeah,
We have some awesome questions
Yeah.
in the
yeah.
chat. So we've got one question, first one from Azus Sandoval. I hope I'm saying that correctly. Once you do a build pack build, can you show how we can modify that image if we wanted to layer your own CLI tool in there? So I'm not completely sure what that means, but it seems like how do you modify that image in that sense that you were just talking about, right? Where there's that seam between, yeah.
Yeah. So I think there's a handful of ways, or like two ways I can think of doing that. The kind of like, I think, brute force way is if you don't know like build packs at all, but you get a build pack image, it is in the registry or in your Docker daemon. So you can't just write a Docker file, right? Like we could just write a Docker file that, you know, will inherits from this image, right? And then you can do whatever kind of thing you want here that goes and installs a tool, right? And then
Got
you
it.
just run a Docker build. Of course, the downside of that is like now you're modifying that image with
Hmm.
stuff, but and so your mileage may vary of like depending on where you put that file or other things, like is it technically safe to rebase or not? Like that's kind of,
Right. That breaks the
exercise to the
guarantees that, yeah. So doing that breaks the guarantees you can, some of the guarantees you get from using the build pack tools, I would
yeah.
imagine. So
Um,
that's related to the next question, which is my current understanding is that building a custom build pack is the most robust way, but then the quickest is to extend the build pack image via the Docker file. So that's what you were just showing.
yeah.
So, okay,
Yeah, and so I actually have, we have the samples repo if you go to github.com/buildpacks/samples. And then also on the documentation page, there is like how to build your own build pack. But I did just pull down kind of a quick, uh, kind of hello world build pack kind of thing that I put together from the samples. And so essentially, build packs are actually not that complicated, but they can get complex in the sense that the Node.js build pack is not a simple build pack, right? Like it's doing a bunch of detection and things. And I guess we could pull it up on GitHub at some point if we want to take a look and we have time. But essentially, there's two files that you really need to define as part of the build pack process. So we saw that detect phase where you saw that the build pack was being detected. And so this is that detect script. So it's essentially its job is to do two things. It's to decide that if it should be part of the build pack plan in the sense that should this build pack be run, right? Like, and so that's what you really try and decide and detect. And then there is this thing for build packs being able to interact with each other through kind of this plan that you're building. So you can essentially we use TOML for everything, so that's kind of the standard we have for stuff. So essentially, you're outputting TOML as standard output, and in this place, and this is totally optional, so you can skip this part if you don't want to deal with interacting with other build packs. But essentially, you can have things that say like my build packs can provide a thing, or my build pack requires this thing, and these are just key values. And so it allows essentially other build packs to essentially like maybe what your build pack does is provide a thing, you expect someone else to like require and consume that thing. And so kind of a little more advanced side of it, but that's essentially what the tech does, if that makes sense.
yeah. So I think one thing that you're kind of highlighting with build packs is traditional Docker files don't lend themselves to composability of different container images together and different layers together, whereas build packs has composability front and center as part of its UX, right? So the idea here is that you're providing an advanced tool that allows you to compose any kind of dependency graph, like some kind of DAG of container images, essentially, right?
Yeah, and the reason this is important for kind of the interoperability with that side of it is like I think it's very common for if you're a company that's interested in like taking on build packs, we get this question all the time at the booth at KubeCon is most of the time, like I think people aren't doing something super special for like a standard language, right? So oftentimes it makes sense to take a look at Paketo or Heroku or Google who have already done a bunch of the work of like battle testing like how Java is built, for instance, right? Like what we're doing in Maven isn't proprietary. It's not special, but it's like a thing you want to do and you probably don't want to build it yourself. But like I was mentioning, I think it's very common for companies that are Java shops, for instance, to have a very specific Java runtime that they need to use because that's part of the contract. So like this happens internally at Salesforce as well. And so one of the things you can do is you can take the bulk of like these other builders build packs and then replace out that like Java engine part of it. Like so I'm going to supply my own like version of the thing and then use the rest of it. And those build packs work without having to basically be like, nope, I got to like rewrite the entire Java build pack.
Got it. So we just continue with some of these questions. The
Yeah, yeah,
next
go
one's
ahead.
pretty interesting
Yep.
because this is coming up more and more and more over the last few years. So Jesus is mentioning that he's working or they are working with machine learning engineers, trying to build custom images for machine learning models, which is obviously the workload du jour these days. But one thing is that these images are bloated, and he was using build packs to kind of drive down the image sizes and helping with the pruning. So well, there's two people. One question is around how does the caching system work with build packs, and does it support remote cache instances? And then the other side is, um, you know, is there any advantages with respect to machine learning images?
Yeah, th those are great questions. I guess going through kind of the caching thing is I don't think we support as part of like the spec or anything remote caches though as a platform as you're doing stuff you can pull the cache from somewhere. So one of the things that happens is that uh I believe by default with pack we use volume mounts. So we volume mount essentially. So when you're doing a build here for these different things, when you're specifying, wait, let me scroll up. When you're specifying these layers and we're exporting them, one of the things that's kind of neat is that you are essentially, as a build pack, you get to define uh, essentially layers in um, you get essentially a layers directory, your build pack directory, and then you can essentially have any number of folders, and each of those folders gets turned into a layer. And there's metadata that gets associated with the layer that you can define in the layer.toml for it. And the three kind of flags that you can set are, do I need this at launch time? And so launch just means it gets exported in the final image. Do I want this at build time? And so you can essentially like if you have say like the M2 cache for Maven or something along those lines, right? You can cache that layer, but it won't result in if you don't set launch to true, it won't end up in the final image. So I think this is probably akin to like the multi-stage Docker builds that people kind of do to kind of work around some of this stuff. And then cache essentially is also a flag, so you can essentially allow a layer to be cached, which then gets stored in kind of the volume. So on a subsequent build, it gets pulled back down. And so you can kind of use it. And then there's a metadata field essentially where you can set key value stores of anything that's related to this layer, right? So like for a Node.js engine layer, you would store like the version of Node you're using probably, or maybe probably even like the base image or something that is running. So you know when it's updated that you actually need to blow that cache away, right? And so you can kind of store what you need for those layers, and then you can choose at the build pack. You have essentially high fidelity of like you get this cache layer back and you can essentially choose to just use the whole thing. You can choose to just delete the whole thing. You can also choose to like just use like add things into it, remove stuff from it, right? So an example of that would be if I was to add a um, module to um, you know to my package JSON in this. trying to remember is it just npm add? What is left pad still a thing? I guess I don't even have npm on here. But if you were to like make a change here, right? Like, let's say I wanted to, what is a newer version of like if I wanted to
5.2.
make a change here,
I don't know.
yeah.
5.2.
Yeah.
Does this break with my
5.1.1.
lock file? It might break with the lock file, but if I was to make this change, it'll probably break with the lock file because I have to actually run it
Yeah.
locally, I
Install.
believe.
Yeah.
Yeah, and I don't have installed. But if I was to do this, right, like it would go and it would reuse the cache. Yeah, so it's gonna yell at me here, but essentially, like it would just go and add that. And so normally in Dockerfile, right, like it would blow the cache away, right? And you'd have to reinstall everything. And with
Mhm.
Buildpacks, the Buildpack author gets to essentially make that decision of like when you should blow it away or not. And so as part of the metadata, I would probably store like the node ABI, because if the ABI version changes, I'd probably want to blow the cache away. But if it hasn't changed, I probably don't.
Yeah.
Um, uh, I don't know if that doesn't totally answer the question, but that does talk about like what you can do with the layers. And so as a platform, you can decide to pull in like if you have a remote cache thing and you're storing that, like you could pull that in and set that like as kind of the volume mount. Definitely as like an advanced feature for build packs there.
Yeah, and so you could also potentially set up, like if you're on a Kubernetes cluster, you could set up pre-caching some of those layers already, like the base build packs that might be shared across a bunch of these images. You can pre-cache them onto your node potentially when a new node stands up to
Yeah,
make
and
the rest of this go faster.
I think one of the things as well, like I know the Paketo build packs do this because they have to also support like air gap deploys and stuff as well. Whereas like the Heroku ones are definitely built for, you know, public paths, cloud, expect the internet to be available. That they will actually, as part of some of the build pack distributions, just have a bunch of stuff that's part of the build pack that will just unpack, right? So it
Yeah.
doesn't go and fetch that. So you definitely have the flexibility as a build pack author to kind of tune that experience to like what you want or need. And there is a bit of an art as well to like what you put in the base image versus like what you kind of keep at that layer
Yeah.
level.
So
Yeah.
on that note, Azus mentions that he's hit some of the layer limits, the Docker layer limits, with build packs. Some of the distributed build packs he's using or they're using um, already surpass the layer limit, and so everything just fails. I would imagine that maybe that's something to put into a GitHub issue somewhere, but uh, is there some awareness in build packs around the layer limits and maybe some optimizations that can occur? Because I can imagine that, like, just like if you're not using like multi-stage builds, your layer count can increase pretty quickly, especially if you're composing different build packs together.
Yeah, there was an RFC that came through, and I'm trying to find if we actually shipped it or not. But there was I think the Paketo build packs people have run into this because they do produce a ton of layers. And it is pretty easy to get to that 127 layer limit, depending on what file system you're using under the hood on Docker. And there was a one around basically compacting layers, like that you could compact essentially the layers so you would not run into that limit.
Yeah.
Um, Definitely hit us up. We're on the CNCF Slack and the Build Packs channel. Definitely hit us up for that because I do think we were definitely working on a thing last year related to that.
Cool.
So you're not the first person to run into it.
Yeah. So I'm curious if this is like, because he mentions, let's see. While you were talking earlier, I was working on this problem. I did some research. Found like the Docker conversation where Sebastian and Nigel, like some of our friends are all talking about it has to do with syscalls and Linux and AUFS, and like it depends on how you run things. And so from the Docker side of things, I never see this anymore just from the pure Dockerfile and Docker build standards builds, because everyone that I work with has moved to multi-stage, and that's largely uh, I think alleviated the potential for a production image that has anything close to 100 layers. So I'm always trying to help people, reduce the number of layers, and like maybe we can do stuff in a certain stage, and then we can copy that result out to a different one so that we don't have all those different layers that we were using in that particular stage. We could just have one. I love using the copy from command in Dockerfiles. That's one of my favorite ones. It's actually how I like in my Node.js talks that I do. I talk about installing Node.js in a more minimal image by doing a copy from a node image into another image. So it's like it's not necessarily the official way to do things, but I show examples of how you can do that, and that ends up with one layer to add everything npm or Node.js and npm related. You can do it all in one layer. So there's probably tactics there, but I don't have any like you, the base build pack can't necessarily come from a Docker image, right? Like you've still got that base layer that like Heroku and everyone else builds. Those have to be built a specific way, right? So like I can't, if I have a golden image today, I guess this is turning into a question of my own. Like if I work with, sometimes I work with teams that have the golden images, right? So they have this approved bless image. That thing is often not a single layer, even though it probably just should be compressed into a single layer, because it usually when it changes, it's because of like core OS CVEs. So the caching doesn't really help anyway. Is there a way to take like my golden image that we build with a Docker file and turn that into a build pack base image? I don't know if that's the right words I'm
Yes,
even
yes,
using.
yes. That is a question we get a lot as well. So I was mentioning builder images, right? So this is basically the process. So the make file in this project basically shows the command. So you run builder create. So this is how you can create a builder locally. And so we can take a look at, so yeah, so if we do that, like here, like we can run builder create, and this will essentially replace that builder that I have locally. And then pull, we will um, look at this toggle file that shows you how you can configure it. And so, it's going to go through, pull all the layers that I've said, and essentially, this is how you basically stage together a builder image for people to use, which will be that kind of base image that you want. And here we go. We've created this builder image that I can now, when I run pack builds, essentially pass that as that flag, right? The one thing to be careful when you're doing this is that you probably want to set those pull policies that I was mentioning before, because if this is in like Docker Hub or wherever you're hosting this, it will always try to fetch the latest. And so if you built a thing that you're testing locally, it will override the thing you just built, right? Because there is an image out there that it's trying to pull from. So if we take a look at, what was it? Builder 24, builder.toml. So this builder.toml is essentially what you do to configure a builder image. And as part of kind of this stack thing, you can see we're literally just pulling images from Docker Hub, right? And so we have essentially this one that we're using, and then this image here, and then you can set up mirrors to pull from kind of different places as well. And then all this build pack section below is how you kind of defined where the build packs are that you're pulling from. And then below here, this is where we as Heroku are defining the different groups that we want to have it go through. You'll notice like before for that Node.js, we didn't specify, I was saying we didn't specify auto-detected. These are these groups that it goes through, and this is how it knows how to like do kind of the different groups that it's going to try to detect for. So you can specify that below in the ordering. But the thing you want is essentially this thing here. And so if you want to put in your own image, as long as those build packs work on that golden image that you're talking about, Bret, like you can go and build builder images, and I think people do this a lot with the build packs, because like you can't just pull a random base image off the internet and expect your company's security team to approve that.
Yeah. Yeah. And in relation to that, we have another question. Uh, Jesus is killing it with the questions. Let me find it real quick.
Yeah.
Are there any plans to somehow have a zero CVE build pack image, similar to how ChainGuard offers secure images with zero CVEs or offers an SLA to resolve CVEs in their images? Oh, I just noticed how tiny these little messages are on my screen. I wonder why they're like that. Nobody can read that.
Th that's a great question. We don't have plans as a project to do that. One of the things that you'll notice is I keep referencing uh, Buildpack things that are essentially maintained by companies. And so as a project, we don't maintain an official builder thing. And so there aren't plans for us, mostly because
Mm.
it's not labor free to
Yeah.
do the
Oh yeah,
thing.
yeah.
Yeah, totally.
Yeah. And so a
Is
lot of the times these builders that are kind of built are maintained by companies that have interests and financial backing that align with their company's business to do that work, right?
so I'm sorry. Are you saying there's partners or are there companies that offer this kind of service like ChainGuard, but for build packs? Or are you saying
I don't
companies do
know
it
of any,
themselves? Okay.
which is mostly why I'm like saying I don't know of any plans. But like if a company wanted to build a thing on top of the chain guard stuff, you totally could. But like we as a project don't essentially do that because
Right.
it's labor intensive to
This is open
essentially
source,
maintain that
right?
stuff. Yeah. Yeah, it's
Yeah.
open source.
Right.
And so all these other open source build packs are essentially funded by platform companies, right? Like Paketo is backed by the Tanzu project, right?
Yeah.
Heroku with the Heroku ones, Google with Google Cloud Run and all that stuff, right? So they are backed because they have commercial interests, even if they're building a thing that's fairly generic.
Yeah, that's like one of my biggest questions coming into this was not, in my world, I work in a military complex. There's 12 military bases within an hour of me.
Mhm.
I have a lot of government here in the East Coast in Virginia. And now that we have, you know, Docker's, like we've had all these companies recently announce, zero CVE hardened images. ChainGuard's been doing it for years. I've been big fans of that. And I was very interested in like, does build packs make that easier? Does build packs make that harder? Or, we're there are in some circles there like you don't ship a CVE to a known CVE to production unless you have researched it and made sure it's not gonna happen. Nothing's gonna happen with it. Like you basically have to make exceptions for every CVE at whether if I've worked at companies where if it's higher critical they won't ship it. I guess more government and military would get more strict, possibly even not allow lows. So are you seeing people come up with solutions for that in the open source community? Like not necessarily to offer to others, but like are you seeing people in the Slack servers and stuff talk about how they approach this?
I personally haven't seen too much discussion around it on our end necessarily. I think a lot of people essentially that I work with essentially are at big companies where they have contracts with your Red Hat or whatever, right? And so they use essentially those images because they have a support contract with them.
Okay.
And so people are building stuff on top of your like RHEL 9 or kind of, what have you, where they essentially have a company they can, I feel like, call up on the phone or
Right. But those
have
those
that
are
support
those
contract.
are when you're talking about those are like standard Docker built images, right? Like so they're having to bring them into BuildKit like you did earlier. Um
Yeah, exactly. So what they do
okay.
is they do something like this, right? Where like they will take build packs that exist to write their own. Wasn't this KubeCon, but I think it was the KubeCon EU before, I believe, where Bloomberg went and talked about how they were leveraging build packs internally for their AI ML platform. And I know they use a bunch of the Paketo build packs, not all of them, but the ones they do. And so their customers are data scientists who don't, you know, containerize apps as their job. Like their job is to
Yeah.
do AI ML work, right? And so bill packs were a huge boon for them, but they do work in the financial industry. So there's very stringent requirements around productionization and other things. And bill packs were a way where they weren't automatically like trying to magically write Docker files on behalf of their scientists, and they were able to use bill packs for that. But I know they, or I'm confident, trying to remember the talk. I don't remember all the specifics that they talked about, but I'm pretty sure like, yeah, like they have their own base image. They don't use the Paketo ones, right? Like, and they maintain and groom all that stuff like very strictly in-house, right?
Yeah. All right, got a couple more quick questions. Hopefully we can do rapid fire. Did we
Sure.
talked about have we talked about the caching system with build packs? I think we've covered a little bit of it, but I'm not sure if we were
Yeah.
addressing this question directly. Like, how does the caching system work with build packs? Does it support remote cache instances? Did we answer that? I didn't keep track of every question Nirmal was asking from chat. So
I think we talked
We
about it
did.
a
We
bit.
did.
Yeah. Okay.
We did talk about that. So I think we've covered a lot of ground, Terrence, with these
Yeah.
questions, and there's a lot of use cases where build packs can help solve some issues. Uh, Before we jump into the last part here, are there any other features that we didn't cover that or where are build packs going? Maybe you want to cover some of the like roadmap items, or what's the future of build packs in the next few months or year?
Yeah, that's a great question. The roadmap stuff. I mean, it's always somewhat kind of, I think, flexible based on like the industry continuously changing around us as we're seeing now. Like I think our support for SBOMs, that example, was a thing that kind of was not a thing that was planned that we shifted to in the middle of the year because of the White House bill and all that stuff
yeah,
that happened there. But and I could see similar things happening with various things in AI. A lot of things that we are looking at right now have been we're trying to work on, we just got an RFC kind of merged through this year that was one of my own that I'm excited about, which is the idea of essentially an execution environment. So right now, build packs are really built around, I think, production, right? Like that's the main use case, I think, that came out of both Heroku and Cloud Foundry that started the project. If you're Bloomberg, for sure, like that's the thing you care about, right? It's like how to production these AI apps, right? And so that's kind of where the project has been for the last 6 years, I would say. And then, but like I think Bret mentioned like different environments at one point with Dockerfile and kind of dealing with all that. So we get a lot, we've been seeing a lot more customers that are like, how do I, okay, great, I've moved to build packs for production, but now I have to maintain this Docker file for dev and test. Like that kind of sucks. So I'm basically having to do like a bunch of the work that build packs was in theory saving me. Like what's stopping me from basically taking that to like then also doing the production side of it, right? So um we essentially have this execution environment where build packs as an author can be aware of like, oh, if I'm doing an npm install, maybe I will keep like the dev test stuff and not like prune those out. And so having that capabilities one of the things that we're hoping to kind of ship out this year.
yeah. The wild card question that we can wrap up with is uh, Robot asked about Nix in build packs. I don't know if there's any crossover there or
Yeah.
anyone from the Nix community that's looking at build packs. Do you know anything about that?
Is this you're asking me, and I assume not normal?
Yes.
Oh,
Yes.
yes, asking you. Sorry.
Yeah, yeah,
He mentioned
yeah.
Nix
So
flakes. I'm not a Nix person yet, but he mentioned Nix flakes.
yeah, we've
Um,
actually on the Slack people definitely or on GitHub people have asked us about Nix. I think we've looked at it a little bit. I think like with a lot of these kind of systems, right? It feels a little bit like I know Nix is very much like an all or nothing kind of thing. You're either all in on Nix or you're not. Um,
right.
and so I like I'm not saying that you couldn't make it work, but I think if you're going down the next path, you're probably less interested in looking at another tool because I think you're essentially going all in on Next to kind of set up that very repeatable environment
Right.
from ground up, right? And I just don't know where like we would fit in, like why you would choose to use Buildpacks if you've kind of gone all in on that.
Right. Good answer.
Okay.
I like it. I
Yeah.
don't know either, but I agree. Like, I haven't yet used Nix. I've seen Victor Farsik, one of our friends on his channel, talk about using Nix, and it didn't convince me yet to switch from Dockerfiles and the traditional way I've used it to Nix. So, but we could have someone on the show that would try to convince me otherwise. But that's a good question, Robot. Thank you. All right, I think we've got all the questions.
Yes. How do folks get involved? Where do they answer their questions? Where do they go next after this show?
Yeah, we're on the CNCF Slack, so you can just always hop into the Buildpacks channel there. And if you're ready there because you're listening to the show and you're interacting with the project, super easy to kind of get in touch with us that way. We're on github.com/buildpacks. There's a discussion forum there. If you have issues, you can file them probably most likely on the pack repo, but there's also an RFCs repo if you want to kind of make an RFC to kind of have ideas and kind of questions there. And then we tend to show up to at least the NA and EU KubeCon. And we will have a booth. So come by and say hi. I feel like one of the coolest things is as an open source project is you don't know who uses your projects most of the time. And so it's always fun to talk to people who are interested or actually users who are actually using your production.
Yeah. Awesome. Yeah. So I can't speak for Bret, but I'll definitely be at the Atlanta KubeCon. Bret, I'm assuming you're going to be there.
70% chance, 80% chance.
Okay. Terence, are you going to be at Atlanta?
Yeah, probably similar to Bret. Like I'm planning on going, so unless something kind of comes up at the last minute, I'm planning on being there.
All right, cool. Well, if any of the listeners are at KubeCon North America in Atlanta later this year, come say hello and take a selfie with us and tell us what your thoughts are on Buildpacks.
Yeah. All right, Terence. Since we didn't do it at the beginning, give us your intro. Who are you? What do you do?
That's a good. I've never had that close a show before.
Yeah. Our editor fixes it later. So now that we're all like, now that we've had an hour hanging out together, it tends to have like a better intro because we're loose. We're flipping the script to see how it goes, and Christy, our editor, will complain to me later that it's more complicated this way to edit, but we're giving it a shot. So, hi, Terence. Why are you here? How are you? How are you doing? Tell us your background.
Yeah, I'm Terence. Like we've talked about, I work at Heroku. I was just telling them before the show, I just passed my 15 years. So, fun fact, I'm one of the 2 pre-acquisition people still left at the company. So, I had a long tour duty there. Have been working on Buildpacks, I guess, like almost for most of that time, right? So probably like 13, 14 years. So it's been a lifelong journey for me and been kind of in this space of just container building. I live in Austin, Texas, where it's okay to eat a taco for every meal of the day, which is fantastic. So, yeah.
Awesome.
It's one of my favorite, speaking of tacos, one of my favorite SNL skits of all time is one called Taco Town. If anyone's watching on YouTube, like look it up on YouTube. It's absolutely hilarious. They take a taco, they put it in a burrito, they put the burrito into the chalupa into the pizza into the chili, and then like it becomes this giant bag of food. And anyway, it's an oldie but a goodie. All right, everyone, thank you for being here. That was random, but thanks, Terence, so much for being here. And this will be a podcast episode. This will come out on the podcast, and this will also be re-uploaded to YouTube in a more edited format later. And Nirmal and I will be back. Let me check the schedule real quick. I didn't have that pulled up.
I don't have it pulled up either. That's on me too.
Let's see if
I'm actually
we're gonna do Embrace. We're gonna talk about open telemetry next month.
Awesome.
Next week is the day before the 4th of July in America, so it's almost a holiday day. So we'll see if we're live streaming next week on the 3rd. And my mom will be here, so she won't be on the show, but My mom's visiting, so I'm going to have guests in the house. Nirmal, where are you traveling? Like, this is the challenge with having a co-host that's in AWS, is you're always traveling.
Yeah, so it's not a challenge, it's an opportunity, Brett. I'll be at New York AWS New York Summit mid-July. So if you are in New York City and attending the AWS Summit, first of all, I would recommend you do. It's awesome. It's a one-day summit on, I think it's July 17th or that week, somewhere in there. And I'll be around. So if you're in the New York area, let me know, and we can definitely meet up, and that'll
Yeah.
be my next trip, and then we'll see where I go from there.
Yeah. Terence, what about you? What's your next, you know?
I think I don't have any real travel plans probably till KubeCon. So
Okay.
you can find me here in Austin. Hit me up if people are in town, and
If they want tacos,
go get tacos. Yeah,
Yeah.
tacos.
go get tacos.
If you both are in town, we should definitely get tacos.
Yeah, Taco Deli or Torchy's, Terrence?
I'm a Taco
Ooh.
Deli fan myself,
Ooh.
but
Hot
they're
take.
both great.
Yeah,
I've only
that
had
is a hot
barbecue
take.
in Austin. Everyone always takes me to barbecue. They don't take me to tacos. So I'm excited to do tacos next time.
Oh, that's a miss. All right.
I know. I'm just saying.
You can just get barbecue in your tacos.
There you go.
People did me wrong. Barbecue in my
No, I mean the
tacos.
barbecue is great too. Barbecue is obviously fantastic.
Before this turns into a taco podcast, let's say goodbye.
All right. Well, thank
Bye,
you everyone
everyone.
for being here. We will see you next week here on YouTube Live. Check out our podcast, newsletter, all the things. We'll see you soon. Bye.
Yeah, build your tacos.
Thank you.
Bye.